The global semiconductor race, high quality microchips, producers, users, and the strategic competition between China and the United States. Semiconductors, often referred to as the brains of modern electronics, are critical to economic and military competitiveness in the 21st century. As nations race to secure and dominate supply chains, high quality microchips have become central to geopolitical tensions, especially between China and the United States. We try to explore the nature and significance of high end semiconductors, their uses, key global producers, and the strategic rivalry between the world's two largest economies. Microchips, also known as integrated circuits, are made using semiconducting materials such as silicon. These components are essential for the functioning of nearly every modern technological device, from smartphones and computers to fighter jets and satellites. As the demand for advanced computing, artificial intelligence, and military systems grows, so does the race for technological supremacy. High quality microchips, especially those under 10 nanometers, are at the heart of this new industrial revolution. These are not just smartphones or the tablets or the PCs, smart TVs or wearables. These are electronic vehicles, autonomous driving, 5G, 6G infrastructure, satellites, radar systems, missiles, surveillance drones, robotic and surgeries, diagnostics, neural networks, machine learning, natural language processing, robotics, and smart factories. The list goes on. The top semiconductor producers in the world right now are Taiwan is the largest one. Taiwan Semiconductor Manufacturing Company, generally known as the TSMC, is the undisputed global leader. It produces over 90% of the world's advanced chips under 10 nanometer, supplies Apple, Nvidia, AMD, Qualcomm, and others. Then is the South Korea. Samsung Electronics is a major foundry and memory chip leader. It competes with TSMC in cutting edge nodes. Then in the United States, Nvidia, Intel, AMD, Qualcomm are global design leaders. US dominates the electronic design automation, EDA, tools and semiconductor IP market. Then in the China Semiconductor Manufacturing International Corporation, generally known as the SMIC, is China's top foundry, but it lags behind in producing sub 10 nanometer chips due to lack of EUV, extreme ultraviolet lithography tools. Other producers are Japan, Netherlands, and Germany. The largest consumers of semiconductors at the world level are China is the number one. Its global share is around 30 to 35%. Because China is the world's manufacturing hub for smartphones like Huawei, consumer electronics, electric vehicles, industrial and telecom equipment. Although China consumes the most semiconductors, a large portion is imported as domestic production still lags in advanced nodes. Then is the United States. United States global share is around 20 to 25% because it is home to major cloud computing and data center providers like Google, Amazon, and Microsoft. Then is the AI chip companies like Nvidia, AMD. Then is the military and aerospace demand. And finally, we see the Apple, which alone is massive chip buyer from TSMC. Number three at the global level is the South Korea. Its global share is around 10 to 15% because it produces major electronics like Samsung and LG are there. Then we see that US versus China strategic semiconductor rivalry. What is this rivalry? We see the United States leads in chip design, software, and tools. It dominates the semiconductor equipment market. It imposes export restrictions on China, example banning Nvidia and AMD from selling advanced AI chips to Chinese firms. It has passed the Chips and Science Act 2022 to invest $52 billion in domestic manufacturing. It encourages friendshoring supply chains with allies like Taiwan, Japan, and the European Union. Then is the China, heavily reliant on imports, spends more on semiconductors than oil. Developing indigenous design firms like Huawei faces bans on EUV tools from ASML due to United States pressure. Then we see the future outlook and strategic direction in this domain. United States, its goal is regain leading edge manufacturing capacity. Intel is building fabs in Arizona and Ohio, strengthening strategic partnership with Japan, Taiwan, South Korea, and the European Union. It plans to ensure secure military supply chains for artificial intelligence, drones, and missile systems. Then in China, its goal is to achieve chip self-sufficiency by 2030, investing in talent development research labs and domestic tool making. It is likely to increase investment in quantum computing and open source architectures, example RISC 5, focused on import substitution and reverse engineering foreign technology. With respect to supply chain fragility, we see earthquakes in Taiwan or political instability in East Asia could disrupt global supply. Likewise, raw material dependency, example rare earth, neon gas from Ukraine. Potential conflict over Taiwan could shake the entire semiconductor industry. Sanctions and counter sanctions add uncertainty in this regard. In the conclusion, we see that the semiconductor industry is not just a technological field, it is now the front line of global power politics. While the United States remains a powerhouse in chip design and equipment, it depends heavily on Asia, particularly Taiwan, for manufacturing. China, on the other hand, is investing heavily to reduce this dependency, setting the stage for a long term technological rivalry. The outcome of this race will shape the balance of economic, military, and technological power for decades to come. Thank you very much for listening. God bless you.